Let's go on and look at chapter 4.1, example 4.2, the second example of that. And so again, we're looking at more computational strategies here, mental math. And again, I have the answers here, but we can at least talk through that and see what's happening here. Again, to solve this problem, change the order. 4 times 25 would be good first, and then times 13. This division problem also follows similar to what we did on this one here. So think about a strategy of breaking that up into 2 pieces. And again, as a fraction, it looks sometimes easier to see. 1710 divided by 9. You can see that is 1800 minus 90 divided by 9. And so then you end up with this calculation here after. And then 86 times 15. This one turns out to be done easier if using distributive property. Turn that 15 into 10 plus 5. So what this really becomes is 86 times 10 plus 5, and then that's where you end up with this process here. And so we introduced compatible numbers. Now this other idea of compensation is really what we've been doing here, this reorganizing or reformulating a sum, difference, product, quotient to one that is more readily obtained mentally, right? It's called compensation. So any method you use to try to solve problems mentally in a way without having to use algorithm is a process called compensation. You're using your number sense and understanding of numbers to solve problems here. And again, here's the solution for these problems so you can get those down. The key part is, again, you understanding the different ways. And again, it's not about memorizing all these methods. That's not as important as just being able to think about using some methods, right? And then most people use methods and then, oh, that's the without actually knowing there's a name for it. But the book does name these methods. And so you have these problems solved using some of these methods here. And again, the word compensation is just any process that you use to reformulate, change, alter your equation to make it easy to calculate. And so you have all these different examples here. You can see how they get reformulated to solve these problems here. And so just go ahead and you'll be able to pause and look at some of those things. Again, just looking at some of these here. Again, the names aren't as important, but just understanding how we go about doing that. And again, these are ways that, like example on F, 456 times 25. This one's an interesting one here because what's happening is what we're going to end up learning is 456, right? The way this one is solved, 456 times 25 is solved by 456 times 100 and then divided by 4. And so it's an interesting process here. That's what's going on here. Think of 100 as 25 times 4. Right, that's another way to think about that problem there, as to try to solve it. But go ahead and we'll move on with this here to estimation. And actually, before we go to estimation, I want to elaborate on this problem here. So let's finish this. You end up with 456,000 divided by 4. And you're saying, I still can divide by 4, but what's kind of cool about dividing by 4? Dividing by 4 is the same as dividing by 2 twice. So I'm going to divide that by 2, and then divide that answer by 2. So 456 divided by 2 is going to be 228. And then divide that by 2. And you get 114, 0, 0, and that's the answer we get here. This one solves it a little bit differently by breaking up a little bit, but again, that's another way to solve it, and it's kind of a cool way. Dividing by 4 is the same as dividing by 2 twice. Also here, multiplying by 25 is the same as multiplying by 100 and dividing by 4. Again, it's just another way to look at it.